Do you have your measuring volume lab? We went over the top part. We are getting ready to do the procedure. Before we do the procedure though, I want to look at the graduated cylinders we're going to use. The first one is what you should have received in your science kit. Isn't it lovely, nice and large? It holds 250 milliliters of fluid. It doesn't start measuring until the 10 milliliter mark. So I got lucky and I found a 10 milliliter graduated cylinder that I'm going to use for this lab as well. Also, I'm going to be using a pipette. This is not your regular pipette. It also does have graduated measurements on its side too. When we're using our big graduated cylinder, we're going to be measuring from the meniscus. Remember the curve in the water? I'll show you that in a minute. First, I want to show you an Erlenmeyer flask that has approximately 150 milliliters of water in it. Do you see that there? Now I said approximately. Does this have all the tiny little lines like the graduated cylinder has? No. So we're going to see how much this actually is, because we've got a graduated cylinder that's a little more precise, allows us to be a little more accurate in our measurement. And you can see that it is above the 130 mark, but it is below the 150 mark. So now I'm going to practice that good graduated cylinder reading. I'm going to set it down so it's flat and level. And now I'm going to get down at eye level. Magic trick, I'm going to disappear, I'm going to reappear. Okay, so I've disappeared. I'm looking at the graduated cylinder and it's at about 142. Reappear. 142. That's because each of those little lines between the tens is worth 2. Okay? So when we are looking at Erlenmeyer flasks, beakers, things like that, these numbers on the side give us an idea of about how much fluid is in there. They're not meant to be used for accuracy. The next thing we want to do is we want to understand that we have a test tube holder and test tubes, and we have a red Erlenmeyer flask with red water, or I guess the flask is clear, the yellow water, and the blue one. To save us a little time here, because I was using this Erlenmeyer flask to do this first parts measuring, I took red water and measured 25 red and put it in beaker A. I took the yellow flask and I measured 17 yellow and put it in C. And I took 21 of the blue and put it in the flask E. The next several steps, folks, are going to be using this smaller graduated cylinder. And this is very narrow at the top. Dr. Berger's eyes. So I'm going to do the best I can. If you were doing this lab, you would be having the same difficulties I'm going to have trying to get my measurements to be very precise where they're supposed to be. Very accurate. So from test tube C, I need to measure 4 milliliters of water. So I've got my Erlenmeyer flask down. I'm very carefully pouring. Now, I stopped short because I don't want to over pour. See, 4 is here. I've got a little bit of space there. So what I'm going to do is I'm going to take my pipette. I'm going into my test tube C, and I'm going to add to the test tube to get me to 4. And whatever's left, I'm putting it back into that test tube C. So now I've got 4 milliliters. You see how the meniscus is right at the line? Now where am I putting this? Check our procedure, test tube D. So I just simply pour it over just like that. Next step, from test tube E, I need 7 milliliters. Here we go again. Putting it on my nice level surface. Carefully pouring, finding my 7. A little more. Uh-oh. Guess what I did this time? Am I at 7? No. I'm about 0.5 milliliters over. Time for my pipette because it'll reach that far. Putting it back into E. Back into E when I'm not using. And I made it to 7. And this goes where? Test tube D. All right, now step 3, from test tube E again, 4 milliliters. Remember, 4 is tricky. Okay, pouring carefully. All right, I made it to about 3. I'm going to use the pipette again to get me to 4 so I don't over pour. Ooh, just a little more, like maybe a drop or 2. All right, got my 4, and I put that into, from E, 4 milliliters, put it into F. All right, we're on step 4. From test tube A, I need 7 milliliters. Pouring carefully, and I need 7. Almost there. And I poured almost exactly 1 milliliter over. Pipette to withdraw. Back into A. Back into A. Nope, still too high. Overshot. And I got it. Now, where did this one go? Look at your procedure. This was from test tube A, 7 milliliters into test tube F. Now, that was step 4. Step 5, from test tube A, 8 milliliters. How had I realized that? I could have used that the last time. Okay, carefully again. Pouring. Overshot again. It never fails. I'm going to overshoot, right? Put it back into test tube A. Get down at eye level. Look for the bottom of the meniscus. Bottom of the meniscus. A little under, maybe. So I'm going to pull 1 drop from here. I'm going to put 1 drop in. Where does this go? 8 goes into test tube B. Takes a little bit for it to run out. That capillary action works well. And then test tube C, I need to take 3. All right, now remember this one's tricky because it's so little amount of fluid. Overshot. And the what I'm trying to do, see, it's not going to fit. It doesn't reach. So I have to pour this back. I'm about, lost my numbers. I'm about a milliliter over. And you can see here, now I'm just like a couple tenths off. which is probably the equivalent of like 2 drops. And I probably just overdid it. I sure did. But this way the pipette's easier because it fits in the test tube. Down at eye level. I think I'm good. I'm going to move it into a little bit of a better light spot. Looks good. And where does this one go? Test tube B. Okay, now I'm going to set that test tube or that graduated cylinder aside. Check this out. Can you see it? What do you see there? Look at your data table. What we need to do now in our data table, the first thing we're going to do is we're going to write the colors in. Okay? So, ladies and gentlemen, let's not make this hard. Test tube A. This was from Erlenmeyer with red water. So A is red. We used A and C to make B. So what do red and yellow make? Orange. All right, my red's not real bright, not real dark. And then C was yellow. So red and yellow make orange. So A is red, B is orange, C is yellow. D, can you tell what color that is? It was C and E. What do yellow and blue make? Green, right? E was blue. F was blue and red. And when we mix blue and red, that gets to be purple. And this is kind of hard to tell, but that is kind of a purpley shade. So we've got red, orange, yellow, green, blue, indigo, violet. Violet is what this one is. So we've got the colors of the rainbow. But look at the levels here. Are these all the same amount? No, they're not. This one, C, is a little lower than the others. And I think B is a little higher. If I did my measuring really, really well, they all should have come out to the same amount. If you do the math on the procedure, all of these should have had the same amount of fluid in them, but they don't. So we have to measure what's here. Because we're scientists, we're not going to fudge our data, right? So get ready to put the amount of liquid in your blank. I can tell you right now that we're going to need something a little bit bigger than what I was using there at the end. A. Again, getting down on the right level, looking for the bottom of the meniscus. This is right. You know what? We're going to double check it. This is saying it's 10. So I'm going to pour it in, spill it. Whoops. So it definitely should fit. Now I'm going to put it in one of these small graduated cylinders and see if we're about 10. Knowing that I just spilled a little. Setting it down. This is at 9 milliliters. And I probably spilled maybe 3/10. Put 9. Put 9 down. Let me get rid of that. Let's go to B, which I think had more. Our orange. Get down at eye level. Look for the bottom of the meniscus. This I think is at about 11. This one's 11. Orange is 11. I'm going to pour this off over here. Now we're at C. This one was definitely less. So let me put this in a graduated cylinder. One of the smaller ones, because it was definitely lower than the others. I'm going to set it down, get it level. This one is at 8.8. I'm looking at the bottom of the meniscus. Okay? My hand's in the way. I can't see if you can see. So there's 5, 6, 7, 8. It's at about 8.8. Okay? Blue. No, this was green. I can tell my colors. Really, I can. This one is at 10, according to the large graduated cylinder. 10. We're getting to the end. Now the blue. That one's at 10 as well. 10, looking at the bottom of the meniscus. And our last measurement this one's at 11. This one's 11. Now, ladies and gentlemen, I want you to make sure next to where you just put those measurements, you include the units of milliliters right up here, because if you don't have units, it could be jelly beans. We don't know. And if you don't have your units on, is your answer correct? It is not. When you have this data all in, you're going to have a couple minutes to answer these analysis questions. I want you to do that right now.